Welcome to Mode Concept. This is introduction to embedded systems, the practical aspect of it, as per se. Before we look at the various practicals, that is the various labs we shall be covering in this course, I would like us to have a brief overview of an embedded system so that we'll be able to know what an embedded system is all about before we start doing the practicals, as I said. Now, someone might ask, what is an embedded system? An embedded system is a single chip microcomputer that does a dedicated function. We call them single chip because they are usually built on ICs, integrated circuit, and we equally call them computer because they do the function of a computer. They work as a normal computer. They have the processor, they have the memory, and they have the peripherals as the input and output. Then the major difference between them and normal computer is that they just do one task, one dedicated function, whereas a normal computer do many things. Let's look at the applications of these embedded systems. Embedded systems are applied in systems like camera, modern cars, automatic doors, street lights, and so many of them. When you observe the way all these things work, you'll understand that they are made up of so many embedded systems, so many single chip microcomputer. At the end, with all the various single chips, a system is formed. If you look at the car, when you touch the body, it gives out an alarm. When the car drives into a dark environment, the headlamp comes up. When water splashes on the windscreen, the wiper wipes. All these various tasks are done by various microcomputers, not just one, but so many. Each do one. At the end, you now have a smart car, kind of. Just like your smartphone. When you bring your smartphone close to your ear, the screen goes blank. When it's fully charged, the charging cut off. A lot of things that it has in it and made it a smartphone are done by different microcomputers. Each task by one microcomputer. At the end, you now have a smart system. So that is how an embedded system works. Now, this embedded system, or the microcomputer, as we call it, that the single chip microcomputer, I made up the embedded system, has a hardware and a software aspect of it. The hardware is just the chip, the IC. Then for the IC to do the work we want it to do, you have to write a code and integrate it inside the chip for the chip to do the work. So to realize this code, you write the program using a compiler. When you write the program, you compile it, and a particular type of file along other ones is generated. That is the hex file. This hex file is what the IC knows. It doesn't know about any further grammar you're speaking. This hex file is what controls the chip, that is the microcomputer. So to get this hex file into the IC, we bring a programmer. That's where a programmer comes into play. This programmer has a software that it uses. When you finish writing your program with your compiler on your PC, you integrate the program into the IC using this programmer. Now, there is an aspect of embedded system or embedded system development that is very, very important. That is the simulation. Before you do your design and get it work, you first of all design your circuit, run simulation on the circuit, and now if it works well for you, you transfer the design to a breadboard, and now when it's okay, you continue you transfer it again to the Vero board or the PCB, printed circuit board, and solder it there permanently. So that is just the process of embedded system development. You do your circuit design, write your program, integrate the program into the microcontroller, run the simulation, it works. You transfer it to breadboard, it's okay. You move it again down to Vero board or PCB and do the permanent soldering. That's how the whole thing goes. So to make a choice of a particular microcontroller that you will use in your work depends on the work you are doing and the designer as well. The designer will always go for a particular brand of microcontroller that he finds conversant to use. And again, based on the nature of his work, how complex or how simple, you now decide to go for any of the microcontrollers. There are many different shapes, different sizes, and different manufacturers. You can have the ones that have 8 pins, you can have the ones that have 16 pins, 18 pins, 28 pins, and so many of them. Then the manufacturers, you can have the ones from 8051, you can have the ones from AVR, you can have the ones from PIC, you can have the one from ARM. All these different manufacturers have their different configurations for these microcomputers. For the compilers, we have different types of compilers from different companies as well. We have the C compiler, we have the micro C, we have the high-tech C, we have micro basic, micro Pascal, and so on. All these things, the essence is just to write a code, and generate a hex file that will drive the hardware chip. So the compiler can be in the form of an IDE that you use the code editor there to write the code and compile and equally do so many other things as the case may be. In this our various labs, we shall make a choice of micro basic because of the fact that we've really done basic earlier in our program. So it will be good and simple for us to continue with basic, but now micro basic because we are addressing microcontrollers. That's why they are called micro basic, not like just PC basic. No, it's why it's micro basic, but the language is still the same. So that being well said, there are many labs we needed to cover in this introduction to embedded systems. As we call this introduction to embedded systems, we are just introducing embedded systems. We will not just go that deep. We'll just go to the things that you need to know at this level. So before I forget, the simulation software that we'll be using here is Pro Tools all through this work, and the microcontroller that we'll be bringing into play is PIC, Peripheral Interface Controller. The particular one we shall be using will be PIC 16F 628A. So that's the one we'll be using to do our design all through these practicals. So before I forget again, let me quickly highlight the various labs we shall be covering in this course, Introduction to Embedded Systems. Our lab 1, we shall be identifying the input and output ports of a microcontroller unit. And our lab 2 will now interface a LED and LED with the microcontroller unit. In the lab 3, we'll now blink that LED with interface, maybe different colors. We'll blink it, which is equally the foundation of a traffic lighting system. Then lab 4, we'll bring in a transistor into play, that is interface a transistor with the microcontroller unit. At our lab 5, we have digital input and output, getting input into the microcomputer and outputting something. Then at lab 6, we now interface an LDR, light dependent resistor, with the microcontroller. Then at our lab 7, we bring in a relay. We interface a relay with a microcontroller. Lab 8, we'll do a 4-bit binary counter When you press, it counts. You press, it counts, it increments. Then lab 9, we interface a 7-segment display. Finally, our lab 10, we'll do a digital counter that will count from 0 to 9. So when we have done all these labs, we beat our chest and tell ourselves that we have gotten a foundation in this embedded system in readiness to progress to the next level of embedded system. Thank you very much for watching our video. Do well to like the video and subscribe to the channel so that as soon as the various labs starts dropping, you will catch them fresh. Bye.